once again, it's your teacher coming to you from the hospital, so do your best to disregard the noises that you hear in the background. So, we talked already about binary ionic compounds, which remember means that they are made of two different elements. The only difference between a binary ionic compound and a ternary ionic compound is that a ternary ionic compound is made of more than two elements, so 3 or more, which means it has a polyatomic ion in it. Remember, you have 10 that you are memorizing, and you should expect a polyatomic ion quiz again sometime next week. However, there are a whole bunch more of them on your helper sheet, so if you run across one that you don't know, that's when you're going to use your helper sheet. So, in terms of writing the formula for ternary ionic compounds, the same two rules apply. You always write your positively charged ion first, the cation, and the overall charge of your compound has to be 0. So your total positive charge of the cation has to equal the total negative charge of your anion. So you're probably going to choose to do it the shortcut way because, well, let's be honest, everyone likes a shortcut. So you're going to write your symbols, the charges, crisscross, and do the lowest whole number ratio. The only thing or spot where you have to be careful about this is when you crisscross. If you need more than one polyatomic ion, you have to use parentheses. So let's take a look at this first example of copper 2 phosphate. Sometimes this is not super cooperative. So, again, is this an ionic or molecular compound? It's ionic because I have copper, okay? So, because I know it's an ionic compound, it's a metal and a polyatomic ion. I know this is a polyatomic ion because I see this 8. Remember, 8 or ite, it's a polyatomic ion. So I know it's a polyatomic ion. How do I know it's a ionic compound? I'm either looking for a metal and a nonmetal, or it contains a polyatomic ion. So, symbols, charges, crisscross, lowest whole number ratio. So, our symbol for copper, using your periodic table if you don't know, is Cu. Now, remember this Roman numeral 2, this is the stock system. That's telling me the charge on this copper ion. So this is copper with a +2 charge. Phosphate, hopefully you have memorized. What is it? Yes, it's PO4, -3 charge. So I've done my symbols and charges. I'm ready to crisscross. So I have a 2 and a 3. So this 3 is going to come here. This 2 is going to come here. Now, I need 2 of the whole thing here, right? Because in terms of looking at charges here, I know that overall I have to have a 0 charge. So what this is saying is I need 3 coppers with a +2 charge, right, which gives me a total positive charge of +6. To balance that out, I need 2 phosphates with a -3 charge, which gives me that total -6 charge. If I try to combine these in some other ratio, I'm not going to end up with an overall charge of 0. So I have to have these parentheses because I want 2 of these whole phosphates, not just something else. If I didn't have parentheses, this is what it would look like. I don't want 42 oxygens. I want 2 of this phosphate ion. Okay, so again, here's our correct chemical formula for copper 2 phosphate. Looking at our other example of stannic hydroxide, okay, so here we have stannic hydroxide. So again, first question being, is this ionic or molecular? Well, this is ionic, and hopefully you know that because this is one of the 10 polyatomic ions you have memorized. Because it has a polyatomic ion in it, it is an ionic compound. So again, symbols, charges, crisscross, lowest whole number ratio. Stannic, well, this is a Latin root, so you're going to use your helper sheet. You're going to look it up on your helper sheet and see that this is indeed tin. And because it has the ic ending, that means it's the higher charge, which means it's tin with a +4 charge. Hydroxide, you have memorized. It's OH with a -1 charge. So I've done my symbols and charges. Now I'm ready to crisscross. Again, I need to be careful here. Because tin has a +4 charge, I need 4 hydroxides, each having that -1 charge. So I have to have my hydroxide in parentheses. So my formula for this looks like, oops, sorry, a little tired. Okay, this is what my formula for this looks like. Again, this means I have 1 tin, 4 oxygens, and 4 hydrogens. The alternative, if you forget to put your parentheses, is you have this. In which case I have 1 tin, 1 oxygen, and only 4 hydrogens. I don't want only 1 oxygen. I need 4 oxygens. And so I have to have these parentheses here. So that is, in a nutshell, how you write the formulas. Naming ionic compounds, ternary ionic compounds, is the same as a binary ionic compound. We combine the names of our cations and our anions. So if we look at something like KMnO4, again, that same question being, is this ionic or molecular? Hopefully you recognize this. This is a polyatomic ion you have memorized. So that means it's an ionic compound. Remember, our next question was, looking at this metal, is it in a tall column or a short column? Potassium's in a tall column. Remember, that means it only has 1 possible charge. And I don't have to worry about naming it twice. So this as an ion would be potassium ion. This as an ion is permanganate. So the name of this compound is potassium permanganate. And I might spell this wrong. Looking at our second example, okay, of Fe3PO4-2, okay. Again, first question being, is this ionic or molecular? Ionic, here's a polyatomic ion you have memorized. All right. My metal here, tall column or short column, it's in a short column. So that means, remember, it's in a short column, I need to look at my helper sheet. Does iron have more than 1 possible charge? Indeed, it does. So I need to figure out what its charge is. Remember, that means I'm going to focus on this phosphate. Hopefully you recall that phosphate has a charge of -3, and there are 2 of them. So my total negative charge here is -6. That means over here, for this to balance, I have to have a +6 charge. Now, notice I have 3 of these, which means each iron has a charge of +2. Now I'm ready to name this. So again, stock system first because it uses the Roman numerals. This is iron 2-phosphate. Okay? Naming this the other way uses the Latin root. So again, we look at our helper sheet. It's Fer. And the +2 is the lower charged one. So this is Ferrous, O-U-S ending. Okay, because that's the ending suffix that goes on the lower charged ion. And this is ferrous phosphate. So these are our 2 names for this compound. I hope that helps if you had some questions.